All right, can everyone see my screen? So now, yes, great. So welcome everybody. This is the third Stategraph demo day. We're doing these every month. We're super excited to do them. They really motivate us to keep delivering as much as we can, and we love interacting with everyone here. So we really appreciate everyone who shows up. So greatly appreciate everyone who's here. The agenda is we'll do a status report as we normally do, and then demo, and then the best part, I think, is any questions and comments from everyone here. You can discuss what we see, the future plans, what you're interested in, all that. But again, for us, what's really valuable with these demo days is being able to interact with all of you. So thank you again. Just to reiterate, the goals of Stategraph are to provide insights into your infrastructure, and one of the mechanisms that we do, to make that happen is we store your Terraform state as structured data inside of an actual database, so we can query it like other data. We also have a goal of making plans and applies blazing fast by leveraging the graph of the state. So we want you to never have to worry about how large your state file is. And as your organization grows, you shouldn't have to devote a lot of resources into now refactoring your Terraform code just because you hit a certain size. That should be a thing of the past with Stategraph. Now, we're on the third one, like I said. We have decided that it's hard to make every month a banger of a demo day, so we want to adopt an evolution revolution cadence. So on some demo days, we want to take functionality that everyone's seen and show the next iteration of it, or how we've polished it and turned it into a solid product. And then we have the other days where we take and show you new functionality that we've developed that is brand new, doing something interesting and hopefully really cool. And so that's the cadence we're trying to adopt to be able to show both of these. And the reality is they're both really important elements of developing a product. Not every single release can be introducing fantastic new functionality. We also have to take the functionality that we do make and turn it into a solid, dependable product for everyone as well. So today's demo day is going to be on the evolution side. What we're going to show is functionality that we showed a bit last time, but we've polished it, we made it an actual product, and we're here to launch that development that we've done. The other thing I want to talk about is, like a lot of people and companies in the new year, we took some time to sit down and reflect on the previous year, what was important to us, what worked and what didn't work. And a theme that came up quite a bit was pricing. Having talked to a lot of people in 2025, a lot more than we talked to in 2024, we agreed as an organization that we all sort of independently saw this same thing, and that is that we think most of you here are paying way too much for software. There are many competitors out there, and similar products are charging around what seems like a product that's doing more than helping the DevOps people fulfill their jobs day in, day out. And so it becomes hard to buy given the pricing, or it might have a pricing model that just doesn't make sense as you grow. And so we sat down and thought about what pricing model makes sense for us. And what we kept on coming back to is that we don't want to punish organizations for growing. We don't want to punish them for making the right architectural choices. And so that means all of our products have unlimited users and unlimited usage. What you do pay for is those things that take human time to do, because that is where we as a company actually have our costs when we have to do extra work. So for our products, we have a flat monthly fee based on which tier that you want. And the tier depends on a few things. One of them is which features you want access to. The higher tiers have more features. And then going beyond that, if there is work that requires a human to be involved, that, for example, a custom MSA or a security questionnaire, those things where someone has to sit down and do work for a few hours, maybe even more, those things cost more. But when you look at our new pricing page, the maximum that you can pay us is $14,500 per year. So that is, I think, a fantastic price point. Now, we're a multi-product company. We have our existing orchestration functionality. We have the Stategraph, which is actually several products under the same name. And the way that we've looked at it is you should pay for those products that you want. So with Stategraph and going forward, as we expand, you will be able to opt into whichever specific features and products that you want. So you have a tier to choose which set of features are important to you, and you have specific products to choose which one of those are important to you. So we're very excited about this pricing. We think it matches what the needs are of a lot of people that we've talked to, a lot of customers, and we think it makes a lot of sense. And we think it also makes sense in that you're being charged for things that actually cost a human's time, and not just for some arbitrary definition of what's valuable or what we think you can pay for. So very excited about that. So status update, where are we today? Well, today we're releasing the state backend, insights, and inventory. So state backend is a Terraform or Tofu backend where you can store your state in Stategraph, and then it's stored in the database. Insights lets you explore that state at a high level, visualizing it through a graph, but also looking at blast radius. So you can pick a resource and then figure out what resources are impacted if you were to change that. Inventory gives you more depth into what into what is in your state files, information around when they were updated, when it was updated by who, all that sort of stuff. Inventory as well comes with a really sweet feature, I think, which is gap analysis, where by plugging in some cloud credential information, we can compare what is in your state to what is in your cloud accounts, and then produce Terraform code to match that difference, which you can then, now you can control what you have there. In development, we have, of course, the blazing fast plan and apply. We are aiming for that to be the February demo day. So that's going to be pretty awesome. That is definitely going to be one of the Revolution demo days on our Evolution Revolution cadence. We are making a lot of progress there. We're at a point where we're taking the individual components and integrating them with each other, and then expanding the scale and complexity of the things that it can perform. So we're making great progress there. Additionally, we have cost estimation. So a lot of existing cost estimators operate on your infrastructure when you perform an operation on it, for example, a plan. However, because we have your state in a database and we can operate on it whenever we want, if you realize you have come to a deal with your cloud provider where everything has a new price, you can just hit the button and get the new cost of all of your resources. You don't have to force an operation against all of your root modules to make that happen. Cost estimation is powered by our open source tool called OIQ, which is entirely free. You can use it outside of Stategraph. You can use it for whatever you want. It integrates against plans and applies. but we are going to integrate it against Stategraph to get this high-level cost functionality. And then we can also add things like governance. So at the centralized location where all of your infrastructure flows through, you can add checks around what cost increases can happen in a certain state or root module, and what types of resources can be changed, and so on. Additionally, since with inventory, we have this very powerful querying functionality that you'll see today. You will have at your fingertips a SQL interface to all of this, so you can do any sort of SQL operation against your costs that you want to. And in the queue is we have security and governance. This we have a lot of ideas around. We don't necessarily have a well-defined product here, but we have many well-defined features that will go into what that product turns out to be. But the essence here is that we have access to so much information that we can apply all security policies to everything. And in particular, being centralized as well means you can guarantee that if you enable security policy in Stategraph, nobody can circumvent that by perhaps running something locally on their laptop or by modifying their CI/CD to avoid those policy steps. So you get a lot of confidence there with it happening in a centralized location. We can also retroactively apply security policies. So when you want to make a new rule, you discovered that there's some sort of hole that's quite frequent, you can create it and just say, hey, is there anything out there that violates this rule? Let's go in and fix those things. So there's a lot of great features that we have planned for that. Lastly, we have Stategraph Control Plane. You can think about this as cross-plane for Terraform. Now, I know cross-plane supports Terraform to some degree, but you still have to migrate to cross-plane. And one thing that's really important to us is that you should be able to get new functionality and new benefits without it being a massive refactoring project on your side. So what Stategraph Control Plane will be is a control plane functionality that just integrates with what you have already and just turns it into that new functionality. So we're very excited about that too. Of course, we're excited about all these products. That's why we're making them. So now we'll switch over to the demo. And all of the code in this demo actually was done by our CEO, Josh. So not only an executive, but also an engineer. So he's a double threat. I have to watch out as my CTO position could be at stake here. All right, so this screen looks very similar to if you were here at the last demo day. We've moved some stuff around, but that's all sort of cosmetic. The big features I want to show you right now are, one, the query screen. So in the last demo day, we showed off this query screen where you can type SQL in here and then run it and get a response query in the database. Now, the dirty secret in the last demo day was this wasn't actually real. It did these things, but it was actually parsing SQL on the client side and then stitching the results together by doing a bunch of different API calls. So it's very limited. You couldn't, for example, do counts or joins very easily, or group bys or order bys, all these things, all these complex things. Now, though, we actually have, we call it MQL. It is a subset of SQL, and any valid MQL query is a valid SQL query, but not the other way around. We want to make this as close to SQL as possible because we know pretty much everyone knows it. It's easy to find examples online. It's easy to work with. So we have an actual SQL query interface here. Now, this is a very simple example. We can modify it. For example, let's say we want to count all the instances. Here we've got 16 in this tenant. But you can also have some pretty wild queries. We support a significant portion of SQL. So this one implements effectively the home screen. So that first screen when you log in, where it shows the number of active transactions, number of instances you have, excuse me, the number of modules, the last time something was run, we can do that just in this interface. So we have a CTE, common table expression. Each one of these is an individual expression here. So we have the last transaction, the number of instances, the number of modules. We find all those resources with a non-null module, and then we group by the module value, and then we count it here, and then we join it all together, and we do a JSON build object to get the final result. So we run it, raw JSON, and you can see we have 0 active transactions. That matches the home screen, if you remember. 4 modules, 3 providers. It actually said 2 on the home screen, but that's because the home screen was limiting it to the chosen state. And I have multiple states here, and this module, this query goes across all states. And then the last transaction was aborted. So you can do incredibly complex queries here. It's available through the API, of course. So we have a CLI client you can interact with this with, or you can build on top of it yourself. The next thing is gap analysis. So we have your resources in the database, and here I've configured it to have access to my AWS account so it can scan it. And I want to see the differences between what I have in my states and what is actually out there. Now, in this case, the states I have are part of a different AWS account. So everything in my AWS account is actually going to show up as missing. So you get to see like what it looks like for a large difference here. So analyze. Takes a few seconds. And I have a total of 153 resources, unmanaged 134, and then my AWS, these ones cannot be imported. And you get a little breakdown, and then you can see all of them here and page through them. Now I'm going to take one of these, CloudFront, and let's say I want to start managing this resource myself in my Terraform code. Can generate. And this takes a little bit as it's on the back end. We're creating a Terraform file with an import block and then actually performing the plan with the generate config. So Terraform Tofu is generating the actual underlying config for us. And it has to reach out to the cloud provider to do that, fetching all of the necessary information. And here, so we have the generated Terraform file. This is the import block that we have. And then this is the generated resource. So it's a CloudFront, has a random name. This is a website I have behind CloudFront, and it has all these. This is the first layer of generation we have. The next layer that we are adding to this, which is not in this build, is be able to connect this to Claude or ChatGPT or whichever one of these you want, and then connect it with your repo so that we can say, hey, here's the automatic Terraform code. Turn this into something that fits in with this repo for me. So you can connect all those dots and turn to something that you more likely would have written. So those are the 2 big features I wanted to show here. Come back here. So you can get going now. Stategraph.com. We pushed release out today. It's all available. The docs are on stategraph.com/docs. Josh is especially proud of them. They look very beautiful. And please hop on our Slack. This is, especially for everyone here, we want your feedback. We know you're going to hit some interesting use cases, some interesting results. The easiest way to get in touch with us so that we can help you is to join our Slack. So please join our Slack. Please try it out. Get going. And thank you very much. Any questions? Anything to discuss?
There's questions in the chat, Malcolm.
All right, let me see here. So first one from Rodolfo, is it possible to run the generate configuration action from the CLI? Yes, it is. All API endpoints we automatically generate a corresponding, well, not automatically, we generate a corresponding CLI interface to it. So as long as you have an API key, you can call both of those. There might be some distinctions in terms of what exactly you get to see on the result, because, for example, the UI does some work on the resulting generated config just to make it displayed to you in a more aesthetic way, but all that is accessible. Part of this open source. Currently, none of this is open source. We are figuring out the licensing. Yeah. Velocity is still pending, but even without that, what are your benchmarks suggesting in regards to performance increases for large state files between regular Terraform JSON backend compared to their Postgres-based backend? So we don't have any actual numbers on this in terms of benchmarking, and it depends quite a bit on the specifics of your state file and the changes that you're doing, actually. So if you have so let's go at like the extreme success story here. Let's say you have a highly interconnected state file, but you modify a leaf node that has no blast under it. You've just done that. We can take that and turn it into a one node state file with just that, and the time to operate on that is as long as it takes to perform a state refresh on just that one resource. Now, of course, the more nodes, the bigger your blast is. That changes what that scenario looks like. But at the extreme, we can do it as fast as exactly one node. We also have tricks we can do around more interconnected ones, where, for example, if you have a highly connected state and you have the cone, so all those things that node depends on is quite large, well, instead of pulling all that in, we will say, well, we'll just take everything at depth 1 and then do some state and HCL surgery so that we don't actually pull all of those resources in. We can pull in just the static values that those nodes depend on, and we don't have to do unnecessary state updates. And then for the blast of that as well, if it's a large blast, we can decide to iteratively work on it, where we say, well, we're going to do the nodes of depth 1 in that blast, and then see specifically if that impacts anything below it. So we will have benchmarks definitely by the next demo day. But again, it depends on the type of change, the interconnectedness of your state, but those are sort of the extremes of what we're capable of with what we have. Sorry, there's no actual numbers, but we'll get something for you.
You kind of glossed over the question of like what part of this is open source. It's not because of free as in gratis, but as in like understanding like what is happening, how things are working. And if we don't have that, then we're tying ourselves to a company that basically knows everything, and yeah, we can't see what's actually going on with the resources. So that's kind of like a no-go. We can't really actually test anything if we don't know what's happening with our resources or data.
So yes and no on that. We are very supportive of self-hosted. So what you can get now, you can take and run locally. You can look at what's in the database. You can't see the code right now, of course. We are still trying to figure out what will be open source and what won't. Certainly there's pieces of it, but we're also doing quite a bit of R&D in this, and we honestly just don't know what parts of this will come out as open source and what won't yet.
Yeah, understood. I mean, this is like awesome technology that you're doing, and also the approach is great because, like, as in your blogs, doing the graph yourself manually basically is nonsense. So yeah, the approach is great, and I understand that you don't want anyone to just take that over. But yeah, you know, vendor lock-in is more. It's not just self-hosting. It's like vendor lock-in is real with this.
Yeah, absolutely. It's something we're definitely not being blasé about the question of open source and vendor lock-in. We're just early in trying to figure out exactly what that means. But I do want to reiterate that we do take self-hosting very seriously. Self-hosting is very important to us. So at the very least, you can know that your data is entirely secure, even if we don't open source the code yet. But we'll figure out what that is in the future.
Thank you.
Yep, you're welcome. Another question from Adolfo: is there any plan to integrate AI for conversational database queries, maybe using MCP or something like that? That's not on the short list right now. Certainly all of our APIs are open. We have a JSON schema that we can absolutely publish, so anyone can look at that. But that is certainly something we can add to the backlog, and I could see that actually happening like fairly quickly if there's a lot of demand for it. Next question, given the sensitivity of the state file, do you have any specific recommendations to address security concerns in enterprise context? We will get questions about that. You could isolate it, no internet access, but that only addresses part of the risk. There's only used recently all resources. Yeah, so we don't have any magic here. Obviously, when it's self-hosted, you are in control of your database. You are in control of those backups, who has access to that database, etc. Now, one thing that we are, it's not in this release, but it's it's on the short list, is that it is important to us that you can give people query access to the database and restrict both what they can see in the database, but also mask certain parts of what they can see. So for example, sensitive values. The Terraform and Tofu let you specify with certain values in your resources that are considered sensitive. We can take those and make sure that any database query does not have access to those. So you can give access to your whole team and they will not be able to see any secrets. And then going next step further, of course, we could certainly support having arbitrary things that you can mask out of a response to ensure that certain things are not visible to users, certain resources, even attributes in the resource, and so on. And of course, like self-hosted, you get to be in control of all that. You don't have to depend on a SaaS around that. I mean, we agree that state files can be very sensitive, but we're absolutely taking security seriously, and especially we believe everyone should have access to the state file, but you should be able to control what parts they can see. So that is a whole like high level view on being able to securely control the system and configure it. So I hope that helps. Definitely once we get further along, especially talking to security teams, we can see what concerns they have and specifically how we can address any concerns we haven't thought of inside of Stategraph. Great, you're welcome. Anything else? Going once, going twice. Again, please, people, go to stategraph.com today, download it, play around with it, get some state in there, give us feedback. We're very excited. We've been working hard on this, and we're working really hard on the next demo day. I think that one is going to be an absolute banger, and it's going to be awesome. Yeah, so migrating over, Tim, it's you just do a, Tofu init migrate or a Terraform init migrate, where you change the backend. So the Stategraph state backend is just an HTTP backend. You just have to give it some URLs that correspond to the actual state you have, and you're good to go. Oh, yeah, and Josh said there's a migration in the docs. Thank you.
Right. Well, thank you, Malcolm, for the demo and everyone for attending. This was awesome. Josh, did you want to add anything?
Not so much, except for the fact that, you know, like Malcolm said, we're really excited for where this is going, and February is going to be a super awesome demo showing faster planning applies. And yeah, please hop on Slack so we can get your feedback while you kick the tires.
Thank you, everyone, for coming.
Okay, folks.